Welcome back to section 2.6. The second kind of problem that we're going to want to deal with in these percent problems is what's called a percent mixture problem. This is typical in a chemistry setting, so we're going to use it here to help us solve a problem. And to explain how to use this table down here, it's really the same sort of setup that we had when we were talking about our investments. The only difference here is that we're talking about a percent mixture, and in a percent mixture, we say that the quantity of a substance within a mixture is equal to the total amount of the mixture times the percentage amount R of material in concentration in the total substance. Right? So we can think of an example like this one. We say, well, how many gallons of 15% salt solution must be mixed with 4 gallons of a 20% salt solution to make a 17% salt solution? Now, hopefully this should make some sense to you. If we take a 15% concentration of some mixture and we add it to a 20% mixture, that we're going to get a result that is somewhere between 15 and 20%. And in this case, we want a result with 17% salt solution. All right, so how is this table helping me organize it? Well, just like with the interest problems, we set up our quantities so that in our table we can multiply across. So we're going to multiply across, and then in our amounts column, we want to be able to add down. And as we can see, we're not told how many gallons of our 15% solution. In fact, we're asked how many. When you see how many listed, then we're going to say, well, X amount, because we don't know. Right? So X gallons of the 15% solution. But when we add that to the amount of solution that we have for 20%, and we're told we already have 4 gallons, and we add those together, we're going to get our very bottom, which is in this case our total of 4 plus X gallons. Well, which makes sense. If I have 4 gallons and I add X gallons more, I'm going to get 4 plus X gallons. Now, the percent concentration is not an additive column. Notice that 17 is somewhere between 15 and 20, so there's no addition that can happen right here. We're not worried about that. The only other column we're worried about over here is our quantity of substance column. And just like in our amounts column, if we say there's a 15% concentration of salt in our solution, our 50% salt solution, we mean that if we take 0.15 and multiply it by the X gallons, we're going to get 0.15 X gallons of salt. That's actually how much salt is contained in the solution. If we have 4 gallons of a 20% solution, well, then we're going to take 0.2 times 4, and that's going to give us the amount of actual salt in our solution. Now, we would add that down the column, and what we would find is that that total amount of salt will add up, right? If we take whatever amount of salt we have in our first solution plus whatever amount of salt we have in our second solution, it will be equal to the total amount of salt in the total solution. Right? So we add down the column right here, and lo and behold, there's our setup once again. So our setup in this case is telling us that if we take 0.15 times the X gallons of salt that we have in our 15% solution and add 0.2 times 4, well, that is actually 0.8. That's going to give us our 0.17 times the total of X plus 4 gallons to get our total amount of salt. And now we've got a nice equation that we can solve. Even though it has decimals, don't let that scare you. 0.15X plus 0.8 will equal 0.17X plus 0.17 times 4. 0.17 times 4. What does that work out to be? Well, 0.17 times 4. 0.17 times 4. Remember, 7 times 4 is 28. Carry the 2. 1 times 4 is 4, plus 2 more, that's 68. There's 2 decimal places, so we go 1, 2 places to the left. And so we're going to say 0.68. All right, it's time for us to gather some terms. This time I'm going to avoid negatives by subtracting my smaller value for x from both sides. I'm going to subtract 0.15x from the left and 0.15x from the right, which gives me the equation 0.8 will equal 0.02x plus 0.68. So I'm going to subtract my 0.68 from both sides of the equation, minus 0.68. When we do the subtraction, of course, what we're going to see is that we end up with 0.02. Pardon me, not 0.2. Good job, Professor Peoples. It would be 1, 2 is equal to 0.02x. So I have to divide both sides by 0.02 to make this work. So I'm going to have to divide on the left by 0.02 and divide on the right by 0.02. So we're going to end up with this. X is equal to 0.12 divided by 0.02. Lucky for us, this is a nice decimal. We can move the decimal on the denominator 2 places to the right. So let's move the decimal in the numerator 2 places to the right. It's the equivalent of multiplying both numerator and denominator by 100 to get an equivalent fraction, which we know to be the same as saying 12 divided by 2. And therefore, x would equal 6. Well, that tells us then that in this solution we want 6 gallons of a 15% solution added to 4 gallons of our solution. So we're going to get a total of 10 gallons of our 17% solution. But this was what we wanted right here. We were just how much of this 15% solution should we add?